Hello, everybody. Can you hear me? Excellent. Thanks for joining us. So, hope you're enjoying the event so far. I certainly am happy to be back at events with real people after the last 3 years of just talking to people over screens. I hope to give you somewhere around 40-45 minutes overview of what we've been working on and what we've been helping some of our customers do, which is transition from the old way of looking at DAST and using DAST into the modern world, into the world of agile development and CI/CD pipelines. Of course, I'll open up for questions at the end, and I hope you enjoyed this little talk. So, traditionally, we would tell people, hey, here's DAST, take DAST, just go and plug it into your CI/CD pipelines. And companies might try to do that. It would inevitably result in something as bad as this. You push it in, it becomes part of your build or part of the test that's automated as part of your build. The build now balloons from a few minutes to maybe an hour or 2 hours. Developers are sent chasing some false signals, and after 1 or 2 cycles of this, they just yank the tool out, and that's the end of it from the developer's perspective. So what we figured out, and that's the title of this speech, is it's not enough to look at DAST as a tool, the way it was used and the way it was looked at historically, and I'll talk a little bit about that in a minute. When you talk about using DAST as part of a modern pipeline, a modern agile organization's development flow, there's a lot of thinking that you need to do, not only about the tooling, but also about the strategy of how you do that, and especially what not to do. And that's what I'll be talking about today. But let's start from the beginning. What's the problem that we're trying to solve here? Insecure software is the lead contributor to data loss and information loss out there today. It has been the case for many, many years now, and it continues being the case today. Just anecdotal stats from one of the Forrester reports, recent reports, over 40% of external attacks exploit a vulnerability in software. By the way, when we talk about software application or web application, we also include APIs. Obviously, again, modern stacks rely heavily on APIs. Vulnerable APIs or vulnerable web applications are the same. The applications and the APIs end up being the weak link. Organizations are aware of this, and still, when you look at some of the stats and questions that are asked, the organization are aware of the weaknesses and the vulnerabilities that exist in their digital assets, in their applications or their APIs, and still continue pushing new code or new releases knowing that they are vulnerable. Over 80% of organizations still push vulnerable code into production and do it on a regular basis. They do it, of course, because they need to meet deadlines, business deadlines, development deadlines that are, at the end of the day, the primary driver for the organization. Security, as important as it is, often takes a back seat in terms of the velocity of the development side of the house. The other contributor is that once vulnerabilities are discovered, depending on when they are discovered, and again, we'll talk about that later on in this conversation, if they are discovered too late in the life cycle, so too short before the release happens itself, there's just not enough time, even if you're aware of it, there's just not enough time to remediate the vulnerability. It just takes too long at that point and causes too much of a disruption in the release cycle. So what do organizations do? They cross their fingers, they hope that there's enough compensating controls in place, And they get around to fixing it at the point in time when they get around to fixing it, which again, historically is not very promising. It takes, on average, 9 months to resolve or remove vulnerabilities if they are discovered too late in the cycle. Of course, the impact of that is clear when a vulnerability or a breach does happen. The financial toll mounts and mounts quite heavily, and you can see here some of that stats over there. So, what is DAST? Show of hands. Who doesn't know what DAST is? Everybody knows what DAST is? Okay, 1 person, 2 people, okay, brave souls. Dynamic application security testing. So within the big universe of security tool, there is a big continent called application security testing. And these are tools and systems and processes that are focusing on identifying vulnerabilities in the primary applications or APIs that the organization uses or creates. Dynamic, and that continent is called AST, Application Security Testing. It's divided into multiple strategies and tools. One of them is what's called Dynamic Application Security Testing. Dynamic Application Security Testing, the word dynamic means that you're testing a running asset, a running application, or a running API. So in a way, you are trying to attack a digital asset just the same way a hacker would. And in fact, many of the roots of DAST tools, as a category, DAST tools have been around for over 15 years. Many of them started as hacking tools that were used either by black hats or white hats to identify vulnerabilities in applications, again, or APIs in more modern stacks. And it's an automated tool. And what it does is you point it in a general direction. It could be a URL. It could be, again, an API entry point. And it just starts scanning to identify what's called the attack surface. So, where is it that we can try and poke into that digital asset? And then has a big library of vulnerability scans or tests that it then tries to attack those different areas in the attack surface with. And when it succeeds, great, it found a vulnerability. And if it's used by the organization, it would just flag it and notify the organization, hey, there's a vulnerability in there. If it's used by hackers, obviously it will flag them, hey, there is a vulnerability in there. So why is DAST that important and that useful? Well, one thing is it's technology agnostic. So when you are using a DAST tool, you don't care exactly what programming language, what technology stack exists on the other side as you're doing the testing. This is 95% true, this statement. You don't really care. You don't care if it's an app written in Go or in Ruby or in .NET. At the end of the day, the DAST tool treats the asset, because it's a running application, it treats it as an application and doesn't care for the actual underlying technology or code, which means that you can use it even if you have no access to the code base of the application that you're trying to scan. And that's one of the big differences between DAST, which is the Dynamic Application Security Testing, and what's called SAST, Static Application Security Testing, which is yet another approach or method, complementary method, to identify vulnerabilities in apps or APIs. But that approach is based on having access to the code base, so being able to look at the code and from the code derive where vulnerabilities might exist in secure coding. So obviously in SAST, you are technology and language specific. You need to understand the language and technology. One of the advantages to DAST is you don't need to understand all of that. You are just like the hacker. You know very little about the target system that you're trying to attack. The other advantage is it is simple, relatively simple to use. If you have a good DAST tool and you tune it and point it the right direction, it does most of the work for you. Again, unlike some other security solutions where you need to be an expert, where you need to tune a large number of parameters. In the case of DAST, it's a few setups, and then it starts scanning for you and provides the results to you, or, as we'll see in a minute, preferably to the developers themselves. So when do we run, or when do we want to run DAST scans? I don't know how familiar you are with this piece of research. It was published by NIST, and it talks about the time and the cost of remediating issues. Doesn't matter. Vulnerabilities, be they software vulnerability, be they security vulnerabilities or other vulnerabilities in the software development lifecycle. And it's quite intuitive. If you discover an issue early on, in the early stages of the development, say a new code that's being written or a new code that's being modified, if you discover an issue right there and then, it's a lot easier to know what caused it, because it's whatever few lines of codes that were added over the last day or two. It's also a lot easier to remediate it or to resolve it, because there isn't a lot of later code that relies on the part that you're working on right now, making it more difficult to modify the problem in the code that you're working on right now. As you move further and further, what's called to the right, as you move further and further in the process of maturing and testing and release, and get close to release of whatever it was that you modified in the code, the more difficult, the more expensive, and the more timely it becomes to resolve that vulnerability. Again, because it becomes more difficult to identify what the root cause was. By then, there's a lot more code that was added by other developers into that code base, and figuring out, kind of peeling the onion and figuring out what caused the vulnerability becomes more difficult and time-consuming. Also, you're much closer to the release date. The pressures we talked about earlier of, hey, the business needs this release to happen next week, make it a lot more difficult to spend the time then to go back and, again, triage, figure out what the issue was, resolve it, etc. So the earlier you can find an issue, the earlier you can find a vulnerability, the better it is for the organization. So in the original days of DAST, I'm sorry about the line splitting there, it wasn't on my machine here. In the old days when DAST started, so we're talking 10, 15 years ago, the world of application development was mostly a waterfall world. For people who are familiar, development happened in a chunk of time, say 2 or 3 months. After that, there was code freeze, and you had somewhere around 2 weeks to do all of the testing, identify any problems that you can, go back and quickly fix the ones that you determine are critical to fix before the release, and then go ahead and have the release. And security testing using DAST tools was part of that life cycle. It would happen at the end, after the development was done, in the QA phase, as part of the QA tests that were happening that included performance testing and functional testing, which means that they were run manually. They were run by the application security team. They were run infrequently, so you would run them maybe 2, 3, 4 times a year whenever a big release happened. And the information that was gleaned, the vulnerabilities that were identified, were reported, literally a thick report, to the AppSec team, who then need to triage and figure out which of these are important, which of these are not, and then go and negotiate with the development team which ones will be entered into which fixed schedule or not. Will just sit there on the backlog. In that world, a tool, a DAST tool, that would have significant amounts of false positive was still okay. 30, 40% false positive, historically for DAST tool, was acceptable for the organization for 2 reasons. One is because the user and the consumer of the information was the application security professional. They are obviously security experts and can tell fairly quickly, hey, this is a real signal, this is probably not a real signal. The other is because at the end of the day, as we said, most of those didn't get fixed, right? Most of the vulnerabilities that were identified were just put on some backlog, and having false positives in there wasn't the end of the day. The important thing is that it balanced the need for speed on the one hand, the speed to develop and release, back then under the waterfall model, with the security, the need to at least do some rudimentary security scanning before you put the asset out there. And then agile development happened. We're talking 10 years since it's more or less started, a little over 10 years, but really hitting large number of organizations in the last 6-7 years. The movement away from releases that would take place in a schedule that lasted over 3 or 4 months into development and release cycles that happen on a weekly basis, on a daily basis, and in some cases, even multiple times per day. And that change obviously is a huge change in many aspects of the software development of an organization. Now, no need to go into them here, but they do obviously also have a big impact on the security posture and on the risks that are now associated with continuing to use DAST the way it was used under the waterfall model. So you're talking now about builds that happen every day rather than once every 3, 4, 6 months. You're talking about hundreds. If you think about it, if you release, if you continue doing 3 or 4 pen testing or DAST scans a year per asset, per one of your applications or your API, now you might have 100 releases happening between 2 of these scans, right? Before, if you had 4 releases a year, you did 4 scans, you more or less matched the release cycle with the scanning cycle. Now, if you scan in January, you scan again in June, you have gone through 100 or more releases in the interim that were not scanned. And they're not scanned because there is absolutely no way that the centralized application security team, who's typically a relatively small team, we'll see that in a second, there's just no way that they can do daily scans across all of the applications and the APIs that the organization is constantly tweaking, improving, and changing. So we talked a little bit about the AppSec team being a critical element of this equation, right? I mean, they were the people who were using the DAST scanners. Those are the people that interpret the results, the triage based on the results, and determine what they recommend get fixed or not. The ratio of people in the organization between AppSec and developers, it used to be about 1 to 100. It's moving closer to 1 to 500 in larger organizations. There's just not enough AppSec people, and there will never be enough AppSec people in the organization to use DAST the way it was used under the waterfall model and still be able to do testing whenever a new release happens. Just, again, the numbers just don't add up that way and never will, which means that the only way that organizations can look at DAST as a serious mitigation effort on in an agile world is to let go, not expect the AppSec team to be the ones that are running those scans, not expect them to be running them manually, literally make it a team sport, engage and get the developers to actually be part of the process. Of course, that carries a lot of implication into how you use the DAST tool and what features and capabilities that DAST tool needs to have, and that's what I'll be talking about in the rest of this, in this conversation. So if you look at, again, historically, DAST scans used to live here, very close to when the release would happen. When we talk about shift left, and I'm sure you've all heard the term shift left, and you can see it kind of visually here, we talk about taking DAST and implementing or embedding it earlier and earlier in the software development lifecycle or in the CI/CD pipelines, which is really the factory that enables the agile SDLC. Run tests during integration, run tests even as early as unit tests. Run DAST scans, sorry, even as early as unit tests. The advantage here, is think about that slide, the NIST slide I showed earlier, is not only are you able to scan every release before it happens, you are also able to identify issues earlier on and therefore give the developer a chance to resolve them immediately, not after he or she moved, changed context, moved to work on something else, and now need to go back and figure out, hey, did I do this or not? And if so, what was it and what do I do about it? So I think from a reasoning perspective, most of you will agree that embedding DAST or putting DAST earlier in the SDLC would make sense and would create a lot of value for the organization. That being said, it's not that simple. First of all, it requires clear responsibilities, ownership, and integration between different teams. In this case, it's the security team and the development team. The development team needs to know that they have a stake in this, that they own some of the problem, I would say a big chunk of the problem of vulnerabilities that exist, as long as it's vulnerabilities that result from the application itself or reside in the application itself or in the APIs. This cannot be a side matter that only the security team cares about and they are not bothered with too much. And there's a lot of resources out there and a lot of efforts out there, and I can point you to at least one that we are related to called We Hack Purple, efforts to educate developers on A, the importance of secure coding, and B, methods to improve their coding from a security perspective. But they need to know and they need to want to be part of the solution. Without it, it won't succeed. Integration is critical. So when you talk about developers, and I'm sure there are developers here in the room, developers have certain habitats that they like to live in. They love to live in their IDE. They can move out and live in their Jenkins or whatever their pipeline tool is. They live in their Jira. Nobody loves Jira, but everybody uses Jira. That's the ticketing system that developers use, and they have to use it. If you try to introduce additional tools, additional user interfaces, and ask them to use them, you're just creating a huge friction for you in terms of adoption. So whatever DAST tool the organization adopts and deploys in the SDLC and close to the hands of developers needs to be fully integrated into the environments and the tools that they are using today. So into the IDE where relevant, if it's a SAS tool, static analysis tool, into their existing pipelines, and most importantly, into their ticketing system. A security vulnerability at the end of the day, if it relates to the application, if it's not related to your routers or your network, if it's related to the application or the API, a security vulnerability is a bug, just like any other bugs. And it needs to be treated as such, and it needs to be triaged in the same systems that are used to triage bugs. There can't be two systems that developers now need to move and prioritize activities between. And a DAST tool for a DAST tool to be successfully implemented and used in the CI/CD pipeline, it's not enough to kick off the scans from the CI/CD pipeline automatically. It's as important that the vulnerabilities or the results and the findings make their way automatically into the ticketing system so that they can be prioritized and triaged in the ticketing system itself. And last, remember I mentioned in the sort of waterfall prehistoric world, DAST tools with 30–40% false positive were still okay because the target audience was different. Well, in this case, the target audience is the developer, right? The developer doesn't run the scan runs automatically for them in the pipeline. But they're the ones that are going to get the ticket in their JIRA, in their ticketing system. And guess what? If they get 3–4 tickets, they go and try and investigate and figure out that those 3–4 were false positives, that's the end of it. They will just not continue to use the tool, and frankly, justly so. I mean, the fact that we got them interested enough in security is an achievement in and of itself. Wasting their time chasing down, irrelevant rabbit holes is certainly not going to make big friends out of them. So a DAST tool that is relevant for an environment that's integrated into the pipeline has to be one that has a very, very low false positive rate in it. So what is the right way to look at it? What's the right DAST platform for shifting left or putting security closer to the hands of the developer? One is full automation in the CI/CD, and it doesn't matter which CI/CD the organization uses, if it's Jenkins or Azure DevOps or GitLab or GitHub Actions. It doesn't really matter. Whatever tool you use needs to be able to integrate into those environments, because many organizations use more than one pipelining or CI/CD platform, and because you might need to change or decide to change your CI/CD platform down the road, so you need to make sure that the tool you're adopting for DAST is able to transition with you. The ability to tailor the scan, and here we're getting really to the meat of it. If you're talking about scans that are now running earlier and earlier in the pipelines, you have to realize what's the price you're paying with that. If you look at, and again, we're working with some large organizations, banks. If you look at unit testing, embedding DAST in a unit test, you're talking about a scan that can run for seconds. They let it run for 15, maybe up to 30 seconds. That's as much time as you have. There is no way you're going to fold a full DAST scan into 15 or 30 seconds. You have to understand what constraints you have at which stage of the pipeline, in terms of time mostly, not only. And therefore, what is it that you can trim and include in the scans at that stage, and which tests and scans need to be left for a later stage in the pipeline. What that means is that you have to have a DAST tool that is flexible, that is able to restrict what type of tests is run at which stage of the SDLC. You can't have a blanket, hey, all of the scans running all of the time, because again, it becomes irrelevant for an environment where scans need to run a lot quicker than they used to back in the waterfall world. The results need to be actionable. Again, unlike in the older mode of use of DAST, in this case, the vulnerability and the information around the vulnerability is sent directly to the developer. The developer, some of them understand security better than others, some don't. The information you provide them needs to be clear, concise, and sufficient for them to understand what's wrong, to help point them in the direction of why it went wrong, and to help as much as possible with remediation advice. All of that was not necessary in the world the way it was when application security professionals were reviewing or triaging the vulnerabilities found by DAST tools, because again, they are security experts, and they didn't need all of that detail and information that the developers would need. We talked about false positive. You literally have to have minimal, less than 5% false positives, or else, again, the tool will just not be adopted, or if it's adopted, it will quickly be thrown back. We talked about the immediate feedback. This can't be a report landing on the application security individual's desk for him or her to review and then send the findings over to their manager and have their manager communicate it to the head of the development team, and have that head of development team go and assign it to his people. Feedback, and that's really DevOps 101, feedback needs to be immediate. Just as the build is happening, the scan is happening, any vulnerability found sent automatically and immediately into the ticketing system, hence the importance of very low false positives, and immediately becoming visible to the developer for which it's relevant, the developer that's relevant for was involved in this specific release. So let's talk a little bit about strategy. I started touching on it earlier. Kind of like backup. When you do backup, you don't back up everything at every point in time. You have a backup strategy. So you back up with incremental backups at certain times of the day. You run them, and then every few days, depending on your backup strategy, you run a full backup again, and then a few incrementals until you run a new backup again. The same strategy needs to apply also to DAST scans in the world of shift-left DAST. You can no longer just say, hey, I'm going to scan everything. I just open the hose as wide as I can, because if you try to do that, if you just take a DAST tool, even if it has integration, integrate it into your Jenkins and just send it on its way, what will happen is, after about half an hour, people are just going to kill the build, take the tool out, and say, thank you very much, but that's not something that we can have delaying us. That's one sure way to lose whatever few friends you still have on the dev side of the fence. So where in the SDLC would it make sense to run a scan? You can start, as I said, at unit testing. As early as unit testing, of course, there are certain things that you can test for back then at that early. You can't still run a complete test. For example, if there's a database component that's involved with this app or API, it doesn't really make sense to run scans early on in the unit testing that involve assets that that piece of code needs to communicate with, because they're not available at that point yet to the developer. So, and we'll talk about which tests make sense for which stage of the SDLC. After the code is deployed, if the developer already does some testing, maybe with mockups or what have you, in a test environment or a dev environment that he or she uses to try out their latest code base, then of course running a DAST scan against that environment at that point makes total sense. Once you get to the testing step of the CI/CD, which again exists, it just exists very dynamic or very very close to the point where the development itself happens. At that point, you can increase the scope of the scan, include more tests in the scan that you're running, and then as you get to the point of releasing, deploying, you can run full-fledged, long DAST scans that involve the entire library of potential vulnerabilities and run on all of the endpoints in the target application or in the API. At that point, you have the time. You've already done the release. It's important to continue doing full tests, full DAST scans. You're not delaying anything at that point. but it's important to see what vulnerabilities still made their way all the way to production. Of course, what you're hoping is that you will catch as many or most of the vulnerabilities that are being introduced earlier and earlier so that they don't make their way into the final release and into production, but things can still slip, so it's important to continue scanning even after the release itself. So how do you run a DAST scan in a focused way and so limit both the scope and mostly the time that scan takes to run? Historically, DAST scanners use what's called crawlers. So you give them an entry point, a URL, and they would start crawling through the pages and look for links to other pages and crawl and collect entry points that way. It's a very lengthy process. It can take hours, depending on how complex and how big the target is. It can take hours to crawl a target and fully identify the potential attack surface or entry points. Some more modern DAST tools are now starting to tackle that problem with the crawler by giving the ability to have incremental crawling. So some DAST tools allow you to do a crawl once, spend the few hours that it takes, and then run incremental, smaller crawls that will just update the map that was created by the original crawl activity. And that incremental crawl is a lot faster than doing a full crawl from scratch. So that's one way to do it. But the better way, especially for really fast scans, if you're looking at DAST scans that need to run in less than 15 to 20 minutes, the best way is to use a HAR file, HTTP archive file, if you're familiar with it. It's a tool used very often by QA people. It's mostly a methodology that was developed for QA people. It basically allows you to record a certain path through the target application and capture that in a file called a HAR file. Some DAST tools know how to understand that HAR file, allow you to load the HAR file, and then run their scans based off of the entry points that are identified in the HAR file itself. It significantly shortens the time of the scan. First of all, you don't need the crawl. It replaces the crawl step. It also greatly reduces the focus and the scope of the scan, which again is a trade-off that you need to do if you're looking to do scans very quickly and early on. So we talked a little bit about how to reduce the scope in terms of what it is that you're scanning. Now let's talk a little bit about what attacks, what type of tests are you running at what stage. So in the old approach to DAST, which is one size fits all, again, you'd take the DAST tool, let it crawl through a big site, spend a few hours that takes, then open up the library of scans and let it just go and try out all of the potential vulnerabilities and all the types and categories of tests that exist in that scan, in that DAST tool. And we're talking about 70, 80 categories of buckets of scans. This could be cross-site scripting, it could be SQL injection. All of these are kind of families or buckets of tests that within exist many other specific scans. If you look at the different stages of the SDLC, it would make sense, again, both in terms of what is available at that point in time, what makes sense to scan for at that point in time, as well as the time that you are allowed to dedicate to the DAST scan at that phase, which again, remember, in the case of unit testing, we're talking about less than a minute. In the case of CI/CD daily scans, maybe up to 10 minutes, maybe if it's running in parallel to some of the other QA testing that is happening. And you can see here, in the unit test phase, it makes sense to run a subset, some elements, some scans, but not others. If you move to the CI/CD, doesn't make sense to run some scans, but does make sense to add additional ones. You can skip the ones that you ran in the unit tests because they already ran and you know whether you found any vulnerabilities there or not. If you move to pre-production, you're looking at expanding or additional scans or other scans that you can run. And then when you're at the final stage after the release or just close to release, if you have the time to run a long scan and not one that will necessarily fail the release itself, then you can say, okay, let's go in and do the entire library of scans. Just to give you a sense, in our DAST tools, in Bright's DAST tool, we have over 7,000 different tests in our scanning library. So it's a big number of tests, and a result, a big number of payloads that we need to be sending to each and every entry point that we're trying to test in the target environment. So again, the key here, and that's what I want to impress on you, is it's not just a tool. It's a tool and a strategy that you need to have in place, combining the capabilities of the tool with the limitations and the requirements that you have in terms of how long can I allow a scan to run, what's my budget, quote unquote, for scanning time in the various stages of the CI/CD pipeline. One more thing that helps to trim down the size of scans and duration of scans, there are scans within the library of scans that are technology specific. So we mentioned earlier, it could be scans for Oracle specific vulnerabilities that the test is tuned for. If you know you're not using an Oracle database, you can just remove those technology-specific tests from the arsenal. That does make sense to run all of them. Again, modern DAST tools will allow you to identify what those technology-specific tests are and just exclude them from the scans. Other than that, set it up for a schedule, full automation, and regular scanning with the strategy that we talked about. So incremental scans depending on the stage and the amount of time you have. A couple of words about APIs. I sort of more generally talked about web applications and API in one broad brush, but in reality, when it comes to APIs, there's a few more things that you need to take into account. If you try and run a DAST tool on an API out of the box, you will likely end up with a very clean scan that found nothing, no vulnerabilities, and it could be the most vulnerable API in the world. It's just that DAST tools, by definition, cannot really understand the API. They need some guidance. That guidance is a schema file, an API schema file. It could be Postman, it could be Swagger or OpenAPI. A descriptor file that describes the API. It's used by the developers. It's used for documentation purposes. It's used for QA purposes, normal QA of the APIs. And it is critical for a successful, again, not just any API scan, but a successful DAST API scan. Having that schema file, having a schema file as much up to date as possible, and having it enriched with relevant data. So schema files can include default values for some of the parameters that are used in API calls. The more of that information is available, the better quality DAST scan, the DAST scan itself would be. And some DAST tools, ours as an example, allow you to load a schema file. Again, it could be Postman, it could be Swagger, and shows you what imperfections exist in that schema file. So literally lints and helps you identify which information is missing or looks inconsistent in that schema file, and then allows you to correct that missing information directly in the DAST tool itself, in our tool, in our case. But that's really an important thing to remember when you are looking at scanning APIs. Again, without it, if you just scan the API without a decent schema file, it will just not find anything. Now, it's important to remember, we talked about the importance of putting DAST in the CI/CD, and we talked a little bit about the strategies of how to do it without losing friends on the dev side and without really exceeding the quote-unquote time budget and attention budget that security will have at the end of the day from the development side of the house. But it's important to remember that in addition to doing CI/CD based DAST scans, it's still important for AppSec professionals, either internal to the organization or pen testers coming from the outside, to come in from time to time and do deep manual testing as well. The best DAST tool in the world will never replace a very competent application security person or a good pen tester, just because of the human factor. I mean, there's only so much things that you can do with software, and at the end of the day, especially when it comes to fighting out or identifying issues that might be relevant to humans at the end of the day, the hackers, you need the human perspective as well. So don't think that, hey, by integrating CI/CD into a pipeline, that's the end of it. I will never have to look and run manual scans again. It's definitely recommended to continue doing it. What having a good DAST strategy allows you is to free up time. Remember, we talked about the ratio of AppSec people and developers, 1 to 100 or 1 to 200. If you run a good DAST program, you're taking off the table a lot of manual work that otherwise would have to be done by the application security person, or for that matter, by an external pen testing firm that you will hire and pay quite a bit of money for, and you're freeing their time to do the higher the higher value is what I was looking for. The higher value type of scanning and attacks that otherwise they would not get to, because they would not need to take care of the bread and butter that the DAST tool is taking care of today. All right. So I will say also, don't forget, DAST is not the only technology out there for security testing. It's important to continue looking at the code itself, running static analysis, or in the case of third-party libraries and assets, software composition analysis, scanning for secrets, etc. So what is the last thing I will say? What is the role of the AppSec team in a world where the scanning itself is happening automatically and the results are reported to the developers? First and foremost is to provide the strategy and the governance in the organization around DAST scans. What is it that we're scanning? At what stages do we perform the scans? What do we include? What type of scans we include in each one of these stages? And do we fail builds based on what vulnerabilities are uncovered? And if so, when? Do we have to have 3 high vulnerabilities and only then fail a scan? You know, do we fail a scan? Do we never fail a scan? We just review results after and could finish the build. All of that is strategy and governance decisions that at the end of the day developers cannot make. It's the responsibility and the task of the AppSec people in the organization to make. And the other is to be the knowledge center within the organization when it comes to application and API security. How many new vulnerabilities are being introduced month by month? Track it, right? Are we seeing a decrease in new vulnerabilities being introduced into production? At what stage are we able to find? You want to see that more and more vulnerabilities are found more and more to the left in the pipeline. How quickly are we resolving vulnerabilities, and how do different teams stack up when it comes to their ability to code more securely, and if they don't, identify the vulnerabilities and resolve them. And I will finish with this. We must do dynamic testing differently than we do today. We need to automate, and for that, scanning needs to be fast and accurate. We need the right tools, but not only the right tools, we need the right strategy for it. I will invite you to come and talk to us. We're up on the top floor, Bright Security. Be happy to answer any questions you have. I'll stand here outside and happy to talk to you. If not, see you at our booth. Thank you, everybody.